Hello, we're at the Auditech show and I'm at the booth of Focal Spec and I'm here with Sana. Nice to meet you. Thank you for coming.
Nice to meet you.
What do Focal Spec do?
So Focal Spec builds LCI sensors and scanners, 3D line confocal scanners. And the beauty of our technology, which is unique, is that we are able to combine 3D tomography, 3D topography and also 2D intensity imaging into a one sensor.
Right. And so what sort of organisations use this?
Our main industry area that we are serving is consumer electronics.
Right.
And especially mobile industry. And then in addition to that we have very good applications like printed and flexible electronics. And that is due to the fact that our sensors are able to measure all the surfaces,
right,
including clear materials and mirror shiny materials.
Okay. What sort of materials can they work with, or does that not matter? Could it be organic and inorganic materials and different structures of devices?
Well, a few examples. 3D curved glass of mobile phones.
Right.
There we can measure the 3D dimensions
right.
of the glass, surface roughness, and then of course the dimensions, thickness, gap and offset.
Great.
type of measurements.
And you can tell us a bit about what this screen is showing here?
Okay, so here what we have been scanning, we have here a printed electronics. So what we are able to see is on a sub-micron accuracy. Actually the accuracy goes up to 100 nanometers,
right.
and the measurement is pretty fast. Our sensors are able to measure over 5,000 hertz, meaning that in this one measurement line, if I may show to you a bit more clearly. So here, in the measurement line, we have over 2,000 measurement points.
Okay.
So we are able to measure a bit over 10 million 3D points per second. And as said, here in the picture, thank you, Juha, that we are, I could have. So here.
I'm scanning the laser here.
Yes. So now the scanner is making the actual scanning, and soon I'm able to show you the 3D topographic image of the printed electronics over here.
And did you say it works on flexible substrates as well as rigid
Correct.
substrates like glass?
Correct.
Okay. And what is the speed at which you can scan an area? Presumably that depends on the resolution that you're scanning, but what would be typical?
It is, I say that it is not actually that much related to the resolution, but it's then the depth of view, meaning that if we are able to place the scanned surface very rigidly, then we are still there in the 100 nanometer level. This scanner here, if we take an example of mobile phone, we are able to measure that in tens of seconds. Then again, in inline applications for the sensor, the maximum measurement speed is 5,000 hertz,
right.
depending on the application.
Right.
So pretty accurate and pretty
yes,
fast.
Yeah.
And
oh, very interesting. That's
so here, all right, and here we have the 3D profile now of the scanned area.
How is it scanning the height?
So the technology, confocal line imaging, means that we are spreading the white light into all colors, all the wavelengths. And the wavelength or the color that is in focus with the surface is then measured
right.
back.
Right.
And that means that we don't have to adjust the height,
right.
but the differences between the or the form or the shape of the topography comes with a one scan.
And what are the typical thicknesses that you can measure down to?
The measurement is optical, so when it comes to thickness measurement of a clear material, it's somewhere in a 30 micron. Having said that, then that means that we are measuring the upper layer and then the bottom layer of that clear material. Supposing I'm able to measure as a step height, meaning that I have the clear substrate on top of which I then have
Right.
have the component. The step height is still there in 100 nanometer accuracy.
Okay. Okay. Fantastic. Sandra, thank you very much.
Thank you.
And
It
thank
was
you.
a pleasure.
Great. And thanks for exhibiting with us. May I ask what you've thought of the show so far?
It's been very, very good for us, and it has been a pleasure to meet the old and also hopefully the new customers.
Great. Thank you very much,
Super.
Sandra.
Thank you.
Thank you.